Hello everybody, this is lecture video for Math 1314. We're starting in chapter 2. So, sorry for my echoing. I was just joking. So, we're starting in chapter 2, and this is, I would say, the first, like unfamiliar math. Everything that we've been doing, I really hope was just a review for you. If not, that's fine. I totally get it. You know, we're all in different places. This is where things are a little different. Now, a lot of y'all still probably remember this, but this is also kind of like the new stuff for a chunk of us as well. Anyways, here we go. Domain, range. So x and y. And it's really x values and y values. There you go. I did not spell that right at all. There we go. And really, I want to also add possible x values, possible y values, x and y values that will work in a function in a way, and well, not just a function, but also in a relation. But I'm going to just say x and y values. There you go. So what is a function? I'm going to go to my workbook for the exact answer that I have here, and I'm just going to copy it right down. So here we go. Each x has only one y value. So each x has only one y. But I'm going to put a little star here. I'm going to say no repeated x values. And I'm going to explain that one here in a minute. That's a star, meaning, you know, Chad versus, you know, official. Again, my name's Chad. Hello. So each x has only one y. And so when I'm talking x's and y's, we're talking points here. And this is an x and this is a y point for each one of these. And so does each x has only one y beside it? If so, it's a function. If not, no good. And let's go and do that. So first off, I'm going to say, it says determine if it's a function, state the domain and range. And so does this x have only one y next to it? Does this number have only one number next to it? Yeah. What about this x? Does it have only one y value next to it? Yeah. Same thing here, same thing here. I mean, it's almost like a duh moment. Now, again, it's going to be that we're going to have to see something greater than just that. But for now, it's easy, it's simple, there's no problems. I'm going to also say there's no repeated x values. And so this is a function. So they're going to say, is this a function? And you say yes. And then we have the domain and range that we still have to fill in. Well, they're talking x's and y's. And so what are my x values? I got a 3, I got an 8, I got a -3, I got a -1. For my range, I got a 9, I got an 8, I got a -3, I got a -1. I'm just looking at the second numbers. First numbers, first numbers, second numbers. There we go. Yay! It's the second numbers. Anyways, this is actually no good. My math lab's going to not like it because we've already got a -1. And so we don't repeat stuff. And so on a grocery list, you're like, hey, go get some eggs, go get some bread, go get some cheese. Oh, yeah, and go get some eggs. And yeah, when I'm doing this on a grocery list, my wife gets very upset. She's like, why'd you put it twice? And so same thing here. Just if you got a -1 and you got another one, just write it once, and there you go. Okay, cool. Keep going. Is this a function? Does each x have only one y next to it? Does this have only one y value? Yeah. I know that they're all repeated y values, yet no repeated x values. Just saying right now. Just saying. So is this a function? I'm going to say yes. Everything's fine. And then it says find a domain, find the range. So my x values are 1, 2, 3, 4. And my y values are just a 1. So just put a 1. Now, this one's different. Does this 2 have a 4? Yeah. Does this 3 have only one number next to it? 5. Does this 2 have a wait. Repeated x values. Now, I'm not saying that it's just like automatically that way just for a pattern's sake. Let's go and see what this actually means. I'm saying that we got 2 and 4, and we also have 2 and 1. So like I'd like to merge these together and say 2 is going to both 4 and 1. So does this 2 have only one y value? No. Does each x have only one y? No, it doesn't. Function? No. But again, it had repeated x values. So it's pretty easy to see this stuff. That's the whole conceptual way of saying it, but, you know, repeated x values. Domain, range, pretty simple at this point. We got a 2, a 3. Again, don't rewrite the 2. We got a 5. Range, we got a 4, a 5, a 1. We already got the 4, so there you're done. Okay, keep cruising. They say, hey, function, it has only one y for every x. Every x has only one y value. One y value. There you go. There's the key trick. And again, yes, function, no, not a function, blah, blah, blah. One y value, one y value. Okay, that's what we're looking for. Here we go. It says determine if it's a function or not. And so I want to get, basically my function is y equals blah, 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 blah. One y value, one y all by itself. Here we go. Can I get y equals for this guy? So there's a few ways you could do this. I personally want to add y to both sides just to kind of throw you off, because a lot of y'all want to move the 4x over. That's fine, I guess. That's cool. You do what you want to do, man. Minus 10 on both sides. And y equals a 4x minus 10. Did I get y equals blah, blah, blah? Did I get one y value? Yes. Function. So we're good to go. That's what it looks like. I'm stressing it because the next one. So this guy here, I want to get y by itself. And so you're like, oh, well, this is easy. I've done this before. There's a square, so you square root both sides. Good, because I know your voice sounds like that. Square root both sides. Yeah. So you got square root of x. Awesome. Yeah, that was great. Yeah, we love it, man. Plus and minus. Plus and minus. We got to have a plus and minus. There was a rule about that somewhere. So I'm going to rewrite it in a silly Chad form. I got y equals a positive square root of x. I got a y equals negative square root of x. So essentially I'm saying I've got a positive square root of x and a negative square root of x. There's only one y value for each of them things. I think I got it backwards. Anyways, do I only have one y value? No! There's two of them here. So function? No. I only want one. Just a small little, I don't know, thought. Just a thought here, you know. When you're looking at right here, how many y's do you got? All right, we're good. With that same understanding. That's supposed to say function. Come on, tell me. How many y's do I got? Do I have one y value? Do I have one y value there? No. No, I don't. So I do want to state this, that we're looking at the powers. Look at the power of y. And if you got an even power, then it's not a function. But if you have an odd power, it is a function. And I'm going to demonstrate right quick. So first off, this was a 1 power, by the way. And so therefore it's odd and it's a function. Very good. But what if I had the same thing, x squared plus y cubed is equal to 9, something like that. So I move this guy over, and I got y cubed is equal to 9 minus x squared. How do I get rid of a cube? I'm going to cube root both sides. I put a little 3 there, and it says, oh, now it's something special. So I got the cube root of 9 minus x squared. I'll pause and wait for this one. Yep, exactly. It's only a positive. Only one y value. The odd roots do not have a plus and a minus. The even roots do have a plus and a minus. That's the trick. That's the key there, okay? Cool. Keep cruising. So it says evaluate a function. And this is a perfect time to talk about today's sponsored. I'm just joking. I thought that was really funny the last time I did that. Desmos. And so, yeah, when they say evaluate, they're saying plug it in. And they say f of x, and then they say f of 9. F stands for what? F stands for function. So we got a function, and they say x is equal to 9, plug it in, and we're good. And I'm going to do this the cool way, because this is what the cool kids do, right? This is what the cool kids do. Oh, yeah, look at that. Oh, yeah. Oh, yeah. That's what the cool kids do. Yeah. Waboom. Of course, you could do this by hand, but I'm just wanted to show you we could still use Desmos even over here, okay? Either way is great. This one, not so much. Not so much. So, yeah, we have to actually plug it in by hand and then solve by hand, simplify by hand. So wherever we have an x, I'm now going to replace it with this x plus 7. And I'm going to use in parentheses so that I know that I'm not going to mess it up because, well, you know, I'm prone to doing that if you saw the previous videos. So let's keep going. I'm going to distribute the -4. And this dude here, this guy, you ain't distributing that to. Nuh-uh, you're not. Because there's 2 of them. 4 times 7 is 28. Anyways, yeah, that square means there's 2 of them side by side. You have to FOIL that one. Yeah. There's no cussing here on this channel. No. So stop doing it. It's fun. It's fun. That's what it is. That's the F word we use here. Ha 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 ha. So got 14 minus 4 is a 10. And I got 29 and 28 and yeah, I don't know, it's too much. So calculator, bump bump ba-da-da-dump. And there we go. Cool. Okay. So yeah, that one took a little bit more time, and that's okay. I just wanted to show you what to do. Not if, but when you see this on your homework. This is on your homework for sure. Okay, this guy. So that's a 4 and that's a 2. And so I need to plug in a -x wherever you see an x, which is a little weird, but yeah, okay, fine, I guess. How many negative signs do I got? 4. 2 cancel, leaving a positive. Hey, how many minus signs we got? 2. They cancel yet again. And this is your answer. It just so happens to be the same thing. Ooh. Ah. Smiley face. There you go. So, yeah, I don't know. There's going to be something about that later, but for right now, just yay. All right, plugging in a 3a. Yeah, a 3a in for your x. So 3a. Now, you can distribute the 4 power and the 2 power here, again, because they're being multiplied. You can say that both terms get it either way. So 3 to the 4th power, which I should know, is 81. And then here we got a 9, a squared, and then minus the 7. Kaboom. You will have to write it with an A if they ask for an A. So on my math lab, make sure you write an A. Okay. Vertical line test. This is basically testing to see if a graph is a function or not a function. What do I have written down? I'm just going to dictate this one because, you know, my answers here are so cool. Only one y value. Bam! There it is again! I don't know. I just thought that was funny. Okay. For functions. Okay. Anyways. I'm having too much fun. I hope you are too. Let me show you. Let me show you what vertical line test does because it's like way better than a couple of words. So let's just say I have a cool graph like this. Gotta do better than that, Chad. So I got this cool parabola thing, and I want to see, is that a function? So I'm going to run a lot of vertical lines. And as long as I have one y value every single time, then we're good to go. 1, 1, 1, 1, 1. Everything's 1, 1. Let me test right here. 1, just in case. 1, still 1, and then 1, and then 1. Everything's 1. One y value for each vertical line that I run through that thing. Is this a function? Yes. So that's good. Let me show you another one. Let's say I got like x cubed, something cool like that, right? Now it's cooler. So run vertical lines once, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. 1? 1. Okay, so we're good there. Okay. How about this guy? Let's do a square root. Ooh. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 0? Nah, it's not on your graph. It don't matter. So, yeah, yet again, we're good to go there. Okay, but what if I had like an ellipse or a circle or something like that? Let me try to do that a little bit better. There we go. If I run one vertical line, how many y values do I have? I have 2 y values, and I just tried it once. I just tried it this one little vertical line, 2 y values. Does that work? Is this a function? The answer is no. No. And that's how vertical line test works. It only takes one vertical line to like not work for the whole thing to not work. Okay. So they're now going to talk about whoa, x-intercept, y-intercept. So this is when you cross or touch the x-axis. I'm just filling in these boxes. I don't normally fill in these boxes in class. Cross the y-axis. Okay, good enough, good enough. All right, there you go. Keep moving. So, and we're not going to do this stuff here. Yeah, I call it stuff. It's stuff. We don't need to do that stuff there. Okay, cool. All right, so here we go. We got a graph. They want the domain. They want the x values, and then the range, find the y values, that kind of thing. And in interval notation. And I'm going to show you what that means as we go. So I want to know what x values we got here. And these are the x's right here. These are x's. And so I'm looking for where my graph works. Where's the possible x values? What x values are we using on this graph? And so am I ever using -10? Is there any graph way over here? Nope. Any graph at -5? Nope. Any graph here at -1? Nope. Where do we start? Is right here, x equals 0. At x equals 0. That one's a little better. That one's a little better. Anyways, it's x equals 0. That's where we're starting. So I'm gonna write that out. I'm gonna write that out. So start x equals 0. And then do I have a graph at 1? Yeah, it's right there. Do I have a graph at 2? Yeah. Graph at 3? Yep. Graph at 4? Yeah. Graph at 5? So 4 is where I'm stopping. So I'm gonna say stop at x equals 4. That's what I'm feeling, man. That's what I'm feeling. I also need to feel eraser. So let's get some eraser action here. It's in like, seriously, go away. Go away. There we go. We did it. We did it. It worked this time. So I'm starting at 0, and I'm going all the way to 4. Again, x values right here, 4. 0 all the way to 4. This is my zone. That's my domain, literally. But then how do I put it in interval notation? I'm going to say 0 to 4, and we're good, right? Well, see, this one here is a solid, and solid needs a square brace or a bracket. You're going to say bracket. I say square brace. We're going to have contentions, but we can still be friends, okay? Anyways, this one here is a circle. And so what we often say otherwise is solid is closed, and a circle is open. Okay, so what that means is that this guy here we're actually touching, and this one we're not touching. We're just getting close. We're approaching it. So that's the kind of difference between those two. Essentially, whenever I start talking about this guy here, I need to put a square brace bracket. Here I'm going to put a parentheses. And so I was 0. 0 is a solid. Here we go. Boom. I'm talking about this point now. 4. Parentheses, parentheses. And there's your answer. We're done. That is your interval notation answer for the domain. Let's do it again for the range. So range, I'm starting at negatives going up to positives, just like I did this here. I'm going this way here. I actually start at -9. So -9. And then I'm going to go all the way up until 7. But when I'm talking about -9, that guy came from a solid. This one was solid. So I need to use the square brace bracket. This guy was a circle. And so then you use a parentheses. And there you go. We did it. Now, Your homework will have all types of variations with this, but you still have to follow that same style. You got solids, you got circles. So there you go. X-intercepts. Where's it crossing this X line? As in, like, X equals what? And it's right here at 3. And then it says the y-intercept. Where's y equal to? So y right here, y is equal to -9. You got it. Very good. Let's repeat the whole process over again for this guy. And then we're done, actually. So that's not too bad. Okay, so again, don't need this. Don't need that. Just looking at these guys here. Domain. Notice that this arrow is right here. This arrow means it keeps going forever and ever. As in, I don't know, negative infinity. And this guy keeps going forever and ever as well. And now as we're going to the right, we're going to positive infinity. Again, when I say negative infinity, when I'm talking about domains, I say left. I say right. So like, where's the domain? I'm going to say from the left to the right side. And so how would I put that? Well, I'm going to say negative infinity to positive infinity. And we're done. I don't like that second infinity. Let me try that again. That's better. All right, anyways. So I'm saying left, and I'm saying right. I'm also saying everything works. Everything. Every single x value is possible because I got an arrow on this side, an arrow on that side. If you see an arrow, that means infinity, basically. So find the range. So the range is actually starting at negative. We're going to positive. Notice that this thing is going down. It's going down, 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 right? As in, like, we already started way down here at negative infinity. Negative infinity. And we're going up, up, up until, right there, -1. There's nothing past it. There's nothing up here. There's nothing up there. Parentheses with the infinities. And then on this line, if you zoom in, I don't want to zoom in because it would take forever. If you zoom in, it's actually made up of a whole lot of solid dots. That's how you make a line, is a whole bunch of, like connected dots and all that stuff. Anyways, solid square brace. There you go. Cool. Okay. Now, I know that's a tiny bit on the confusing side, but it's truly something that you have to practice. And I don't say this enough because I don't know. I always just don't say enough. But anyways, I don't say this enough. But math, you have to practice. You have to practice it on your own. Yeah, you're watching my videos, you're going, yeah, I see that. And then you go to the homework, and you're like, what? It's classic. How many times have I heard it, So it's going to happen that you're a little bit confused at times, and even here maybe. Ask me questions. How about that? Ask me questions. That's cool. I love answering questions. I love answering math questions. So please, send me a question. Not here on YouTube, though, because I don't really do that kind of stuff. I mean, if you want to, that's fine. Just say, like, hey, man, a cool video. And I'm like, hey, man, cool, thanks, man. Like and subscribe. Anyways, x-intercepts right here. Where is it ever crossing or touching this line? None. Hey, y-intercepts, where is it crossing this line? -1. Very good. By the way, none, you just click like the none button. There's like a button for that, and you just click it. Okay, -3. So this is a little weird. It says f of -3. Remember, this is f of x. We're saying x is equal to -3, so right here. What's the y value? How high is that? -1. And then at 4. So I start here at 4. What's the y value? Oh, it's -4 this time. Look at that. And now this is the last one. They're saying that my y value is equal to -3. What's the x value? So -3. I know there's arrows everywhere. -3. Hit it. Get it. Good. There you go. You're basically going backwards for that one. You have a y value. Find the x value. There we go. We're done. We did it. All right. Thank you very much. Have a great day.